Hi, in this section, we're gonna write node and mesh equations by inspection. So we're gonna look at the first node analysis by inspection, then later we're gonna look at the mesh analysis by inspection. We give some examples and exercise question. Okay, first, node analysis by inspection. When the all sources in the circuit are independent current sources, we can obtain the node equation by inspection easily. How? If you look at the circuit right there, as we have two non-reference nodes right there. So that's why in the matrix we're gonna have V1 and V2 right there. If you look at the element connected to V1, which is 1 over R1 plus 1 over R2, we call them G1, G2. You can see here. In same node, only this G2 connect between V1 and V2. That's why it's negative V2 right there. If you look at the other side of equation current goes I1 in, positive, current I2 goes out, negative I2. Let's write the second equation. Second equation is same way. When we look at the node V2, only G2 and G3 are connected. That's why we can put G2 and G3 right there. Only G2 between V1 and V2. That's why it's negative G2 right there. We have it. Oh, the independent currents comes to this V2 nodes, only I2 comes there as entering. That's why we have positive right there. Again, in this circuit, every element G means conductance, which is 1 over R. So that's why G times V will be equal I. In general formula, when you look at here, we have G11 and G1K cases. GKK is sum of the conductors connected to the node K. GKJ or JKG is negative of the other connection, basically. Directly connect the other section here. Those are the node equations, VK unknown voltage nodes. These are the current, sum of the current connected to each node. Let's do the same thing for mesh analysis, then we can give some examples. In mesh analysis, we're gonna look at if we have only all sources are independent voltage, dependent or independent voltage, independent voltage make more sense. Independent voltage sources, then we can write mesh equation. If you look at this circuit here, we have two mesh equation, I1 and I2 here, right? So when our matrix will be I1 and I2 right there. If you look at the I1 mesh, R1 and R3 is on the I1 goes. That's why we have I1 and I3. Only I3 is opposite to I1 right there. That's why we have negative R3 right there. Okay. And when we enter the negative side, have the voltage source here, we have that one is positive on the other side here. When you write second equation here, I2 as R2 and R3. That's why you have R2 and R3 right there. Only R3 also opposite the second mesh equation with negative I1. That's why R3 right there coming here. So basically, we can summarize this one in general formula as RKK, sum of the resistance in the same mesh K. RKJ or RJK, negative of the sum of the resistance in common mesh between K and J, basically. I's are the unknown mesh currents, V are the dependent sources, and it goes to the other side as negative, so we can convert them. Let's do some examples so maybe we can make more clear this one here. This is one of the example. So we're gonna write node voltage equation for this one here. We have only independent current sources. We have one here, one here, one here, and one here. We're gonna write node equation, so it's okay. So when we look at here, how many nodes we have it? Non-reference. One of them is V1, one of them is V2, one of them is V3, one of them is V4 here. Okay? And this one is actually same V1 here. This one is same V4 here. Okay. If you look at the node 1, which element connected node 1? 8 ohms, 10, and 2. That's why when we have right here, we're going to have 1 over 8, 1 over 10, 1 over 2. Okay? This will give us a G11. If you look at the same thing for node 2, node 2 here, 10 and 5. So it's going to be 1 over 10 plus 1 over 5. That's give you conductance value. G3, we have 5 ohms connect there. We have 4 ohms connect there. We have 2 ohms connect. So it's going to be 1 over 5 plus 1 over 4 plus 1 over 2. That's going to give you conductance value. When we look at the node 4, we have 8 ohms and 2 ohms right there. Oh, and also another 2 ohms right there. So we're going to have 1 over 2 plus 1 over 2 plus 1 over 8. That will give you G44 right there. You can find G12, G21, G13, everything easily here because G12 between node 1 and node 2, which is 10. So negative 1 over 10. G21 from here to here, that's going to be negative 1 over 10 too also. Same thing. G13, we don't have any element. You can see that's why it's 0. G14, we have it 2, negative 1 over 2. You can see here. We can write all of them in this way. So then, do we know I1, I2? When I look at here, first node equation, I1 is 5 going in, I2 is going out. So it's going to be equal sign 3 ohms. Okay? So when you come to second node equation, only 3 ampere going in, we can write there. For 3, node 3 doesn't have any current. Node 4 has 2 current, 2 ampere going in, 1 ampere going out. So it's going to be equal 1 from there. So if you put them in matrix form, as you will see here, we're going to have 3, 3, and 1. Those are current. These are the unknown. These are the G11, G12, G13, G14. This is G21, G22, G23, G4 right there, G24. We can write them. When you write the matrix form like this, we can use the MATLAB or we can use the calculator to find the whole node voltages. Let's do another one right there. See, we can see directly. Easily here. I have node 1 non-reference right there, node 2 non-reference, node 3 non-reference right there. So that's why we're going to have V1, V2, V3 here. When I look at the node 1 here, this element and this element connect to the node 1. So 1 over 10 plus 1 over 20. That's what you have right there. Okay? Between node 1 and node 2, we have 20 ohms. That's why you're going to have negative 1 over 20 here. Between node 1 and node 3, we don't have any elements. That's why it's 0. It will be equal plus 1, negative 2. So that's why negative 1 is right there. When we write the second equation, between 2 and 1, we have 20 ohms, negative 1 over 20. That's why you have right there. 1 over 20, 1 over 4, and 1 over 5, we have it here. That's going to be right here. Between 2 and 3, we have 5 ohms, negative 1 over 5 will be right there. Okay, node equation number 2, there is no current directly connect right there. That's why it's going to be equal 0. You can see here. When we come to node 3 here, okay, between 1 and 3, there is no elements. That's why equals 0 here. Between 3 and 2, we have 5, negative 1 over 5 here. And 5 ohms and 8 ohms connect to the V3. 1 over 5 plus 1 over 8 is here. Current 3 ampere going in, current 2 ampere going in, 2 plus 3 will be right there. So this is the matrix form. We can solve the matrix form. We can find the value easily. Mesh equation. Mesh equation also is simple too. You can write directly in the matrix form. But look at here. Even I can write the first one with you guys directly here, because when I look at the first one here, what are you gonna have first here? How many? 1, 2, 3, 4 current we have, right? I1, I2, I3, I4, right? Will be equal this format right there. When I look at the first one here, you're gonna have 10 plus 20. 10 plus 20. Okay, I1 and I2, you have negative 20. I1 and I3, oh, hold on, 10 plus 20 plus 5. So we have plus 5 right there too also. Okay, so I1 and I3, we have negative 5 right there. I1 and I4, there is nothing, 0. When you write second equation, second mesh right there, first one, between an I1 and I2, we have negative 20. And you're gonna have here 20 plus 6 plus 8. Okay, I1 and I3, we have nothing, 0 here. And I1 and I, we have negative 8 right there. When you write third equation, we're gonna use this mesh right there, this case here. I1 and I3, there is 5, so negative 5 right there. Okay, I1 and I2, we have nothing, 0 right there. And this will be here 3 case 5 plus 4 plus 2. And I1, you're gonna have negative 2 here. So we have one more equation here. Next equation will be easily here if we write it here from this case right there. I1 and I4, there is no relation, 0. I2 and I4, negative 8. I4 and negative 2 here. And when you look at the resistor, you have 2 plus 8 plus 12. 2 plus 8 plus 12 right there. Let me look at the voltages here. So we have here negative 12 is gonna be 12 right there. I2, we have positive 4. That's gonna be negative 4 right there. I3, we have negative 6. It's gonna be 6. I4 will be negative 10. Negative 10 volts. Did I make a mistake? There is one, oh, negative 10. I'm sorry, negative 10 plus 4. Plus 4. Because when you say negative 10 here and plus 4 coming here, that's why it's gonna be here negative 6 basically here. Did I make a mistake? No, I shouldn't make a mistake. Okay, yes, it's right there. Perfect. So when you have matrix 4, you can write them. If you look at the values, 35, I think 35 should be this one here. This is next one right there. This is this one is here 11. This one should be here 22. The others values are all negative. When you look at the matrix, you will see matrix is pretty much inverse matrix too also, or mirror. You can see it here. So those values are right there. You can use MATLAB to solve this question easily. There is a question here. We wrote the direct equation here. I think we shouldn't give the direct answer, but if you look at this question, voltage source, we have it. We're gonna write mesh equation. That's why it's easy. We can write to. We have I1, I2, I3, and I4. That's why you have this one here. When you look at the first one here, 5 plus 20, 25 is right there. Only this one is against right there, negative 20. Then you're gonna have 0 and 0 right there. Voltage will be negative 5, goes the other side, positive 5. I2, the second part is right there, will be here 20 plus 25, 45. Okay, this is negative 20, for I1. For I3 negative 25. I4 there is nothing, 0. And will be, if you look at the direction here, I'm gonna have positive 20 the other side right there. I3 is this one here. So if I3 and I1 there is no relation, that's why it's 0 right there. Okay. I2 and I3 there is a between here, this one 25 negative 25. 25 plus 40 is 65 right there, and this is negative 40 is right there. We have it coming positive, that's why negative 10 you have the other side. When you write I4, same way, I4 and I1 there is no relation, 0. I2 and I4 there is no resistance, that's why it's 0 right there. You can see I4 and I3 there is a negative 40 right there. So it will be here 20 plus 40 will be 60 I4. If you look at direction of the current selection, so positive 20 will be equal negative 20 the other side. So we have matrix form here. I want you to do exercise on this one again. We will go over one more time in the class.